All right, diving right in today. We're tackling something super important for anyone who, well, reads research. That's statistical power, that thing that can totally make or break a study's findings. We're going to equip you to see right through it all.
Like giving you those X-ray glasses to see the real strength of any research claim, right?
Exactly. And to kick things off, let's think about a simple scenario. You're flipping a coin and you start to get that suspicion. Could this thing be rigged? How can you be sure?
That, my friend, is where our good friend statistical power enters the scene.
Like a detective with a magnifying glass.
You got it. It helps us figure out just how many times we've got to flip that coin to be reasonably sure, beyond a reasonable doubt. Is it just a tiny bit off, or are we talking heads practically every single time?
So that difference, how rigged the coin is, that's the effect size, right?
Bingo.
So bigger effect size, easier to spot. Like a super rigged coin is going to be obvious pretty quickly.
Exactly. But what if it's just a smidge off? Then you might need to flip it like a zillion times to be sure it's not just random chance messing with you.
And that's where power is so crucial. It's like, how much evidence, the coin flips in this case, do we need?
It's the probability of spotting a real effect if there really is one.
So to put it simply, it's the chance of proving the coin is rigged if it really is rigged.
You got it.
Yeah.
In fancy terms, it's the probability of correctly rejecting the null hypothesis.
Yeah.
When the alternative hypothesis is actually true.
Okay. Break that down for us regular folks. So with our coin, the null hypothesis is that it's a fair coin. The alternative hypothesis is, nope, this thing is rigged.
Precisely. High power. Good chance we prove it's rigged if it really is.
Yeah.
Low power, we might totally miss the clue, even if it's right there.
And missing those clues, that's got real-world consequences, right? Especially in things like healthcare or new medicine, stuff like that.
You're spot on. Imagine you're testing a new drug, right? But the study, it's got low power. It might not pick up on side effects that, maybe only affect a small group of patients.
So a false negative.
Exactly. Missing the real effect. And that could have some serious implications. It's even mentioned in the Wikipedia article on statistical power.
So, okay, how can researchers make sure their studies have enough power to avoid all this? Can they just crank it up?
Well, it's not as simple as just turning a knob, but there are things they can do. One of the big ones is sample size.
The number of people in a study, right?
Exactly. The more data you have, the more powerful your study. Think about it. If you're trying to figure out the average height of folks in a city, would you rather measure 10 people or 1,000?
I mean, 1,000's got to be more accurate, right?
You got it. More data, less chance of some random weirdness messing up your results.
Makes sense. So a small sample size, maybe be a bit more skeptical, especially if they're claiming to find something small.
You're getting it. Smaller the effect, the more people you need to be confident in your findings.
Got it. So sample size, big one. Anything else?
Variability. How much the data points differ within a group. Imagine studying, let's say, the effects of a new teaching method on student test scores.
Okay, I'm with you.
Now, if all the students are super similar, their backgrounds, their abilities, all that, you might not need a massive sample size. But if there's a lot of variation, some kids way ahead, some way behind, well, you'll need a bigger group to see the real impact of the teaching.
Because all that variation makes it harder to see the real signal and all the noise.
You got it. Like trying to hear someone whisper in a crowded room versus a quiet library. Quieter environment, less variability, way easier to hear that whisper.
So less variability is always better.
Well, sometimes you can't help it. Think about, animal behavior out in the wild. So much going on, tons of factors affecting what they do. It's just naturally high variability.
Yeah, you can't exactly control the whole rainforest.
Exactly. Researchers have to really think about this and plan their studies accordingly. Sometimes, a bigger sample size is the only way to deal with all that variability and get enough power.
Okay, this is making way more sense now. So we've got sample size, we've got variability. What else? Any other tricks up their sleeves?
Oh yeah, there's this thing called power analysis. It's like before the game even starts, the researchers get together for a strategy session. They can use this power analysis to figure out, okay, how many people do we need to get the level of power we want?
So no more starting a study and then realizing halfway through, uh-oh, we don't have enough data.
Exactly. Statistics by Jim mentions this software, G-Power, which can help researchers calculate the right sample size. They plug in their desired power, estimated effect size, expected variability, and boom.
It's like a planning tool to make sure their study's actually going to answer their question.
You got it. And it's not just about having enough power. It can also help them avoid what's called an overpowered study.
Wait, too much power? Is that even a thing?
It is. It sounds weird, but a study can be too powerful. It can be wasteful, even raise some ethical questions.
I'm intrigued. Tell me more.
Think about it. What if a study uses way more animals than it needs to just to get super high power?
Yeah, that's not good.
Raises ethical concerns, right?
Yeah.
Or think about a clinical trial that recruits thousands and thousands of people when really a smaller group would have done the trick.
So finding that balance. Enough power to find something real, but not so much that it's a waste.
You nailed it. It's a delicate balance. And sometimes being overpowered can even hide subtle things going on or lead researchers to overestimate what they'll find. Tricky stuff. That's why power analysis is so important.
This is fascinating. I'm starting to see research headlines in a whole new light now.
Good. Because understanding power isn't just for the scientists. It's for anyone who reads research, uses it to make decisions. It's like a decoder ring.
Okay, so far this has been mind-blowing. But before we wrap up this part, I gotta ask, is there anything beyond all this, this classic view of statistical power?
You're in luck. We've only just scratched the surface. There's this whole other world of approaches like Bayesian power and predictive probability of success. But to unpack all that, we'll need to continue our deep dive in part 2.
Ooh, a cliffhanger. Well, listeners, join us next time for part 2. We'll delve into those mysteries and more. But in the meantime, what's got you thinking about the importance of all this? We'd love to hear your thoughts.
Welcome back to our deep dive on statistical power. Before our little break, we were about to unlock some of the mysteries surrounding those more advanced tools, Bayesian power and predictive probability of success.
Yeah, those definitely sounded intriguing. I'm ready to put my detective hat back on. But I gotta admit, Bayesian power, it's a little fuzzy for me.
Well, so far we've been in the land of frequentist statistics, the usual suspect in research. But there's this other approach, Bayesian statistics, that has a slightly different way of thinking.
I've heard the term thrown around. It's all about, updating what we believe as we get more evidence, right?
You got it. Instead of just trying to say, this coin is definitely rigged, we say, okay, based on these flips, we're more confident that it might be rigged.
So it's more like a sliding scale, not just a yes or no.
Precisely. Now, Bayesian power, it's a bit trickier to pin down than the frequentist kind, but think of it this way. Given what we already think and the data we're planning to collect, what's the chance that we'll end up strongly believing the alternative hypothesis?
So it's still about detecting that effect, but it takes into account what we already know and how strong the evidence is likely to be.
Exactly. This is especially helpful when we have some background knowledge to work with. Imagine a detective working a case. They don't just look at the clues in front of them.
They consider their past experiences, right? Maybe
Yeah.
profiles of suspects, patterns of crimes in that area, that kind of thing.
Perfect analogy. They use their expertise to inform the current investigation. Now let's shift gears a bit and talk about predictive probability of success, or PPOS for short. This one kind of challenges the idea that statistical significance, finding that p-value under a certain threshold, is the be-all and end-all of success in research.
Because sometimes a result might be statistically significant, but not actually meaningful in the real world, right? Like finding a tiny difference in test scores between two groups, but it doesn't really matter for actual teaching.
That's a great point. PPOS takes that into account and recognizes that success can mean different things depending on the context. It asks, given what we have and what we define as success, what are the chances we'll actually hit that target?
So it's like setting a goal from the get-go, not just is there a difference, but what are the odds we'll find a difference big enough to care about?
Exactly. And that definition of success can change. It could be reaching that statistical significance, but it could also be showing a real-world effect size or even replicating someone else's study.
So PPOS helps us connect our analysis to what we actually want to achieve. It's a more complete view of research.
Absolutely. It encourages researchers to really think about what they're aiming for and if their study has a good chance of getting there.
You mentioned PPOS being used in clinical trials. What does that look like in real life?
Yeah. Imagine a company is developing a new treatment for, say, high blood pressure. They wouldn't just want to show that it lowers blood pressure a tiny bit.
Right, they'd want to show a real difference, something doctors would look at and say, this is worth it.
Exactly. With PPOS, they can estimate the probability of hitting both statistical and clinical success, taking into account things like expected effect size, how much blood pressure varies naturally, and the size of the patient group.
So it's like a risk assessment before you go all in on the trial.
You got it. This is super important in drug development, where trials are expensive and take forever. No one wants to go down a path with little chance of meaningful results.
This is blowing my mind. Statistical power is way more complex than I ever realized.
And there's always more to explore. If you really want to go deep, statisticians like Andrew Gelman and John Kruski have written a ton about Bayesian power and the limits of p-values.
I'm adding them to my reading list for sure. But for those of us who aren't statistics gurus but still want to understand research better, what's the key takeaway here?
Understanding statistical power is like a secret weapon in the world of information. It lets you look at research findings with a critical eye, see past the headlines, really judge for yourself if the conclusions hold up.
Because a statistically significant result doesn't automatically mean the study was good
Right.
or that the findings are bulletproof.
Exactly. You have to think about the power of the study, the effect size, variability, all the things we've been talking about. And ask yourself, does this really matter in the big picture?
So next time I see a study, I should be thinking, how big was their sample size? Was the effect they found really meaningful? Could they have missed something due to low power?
Those are excellent questions to keep in mind. And don't be afraid to dig deeper into the study's methods. Look for signs of a good power analysis, clear definitions of what they considered success, and a balanced discussion of any limitations they found.
It feels empowering, actually. Like we're learning to be research detectives, sifting through the evidence and figuring out what's real.
That's the idea. And remember, research is a journey. Understanding statistical power helps us all contribute to a more informed and careful scientific landscape.
Well said. This has been an amazing deep dive into statistical power. But before we wrap up, I have one last question that's been bugging me. So we've been talking about how to, evaluate one study at a time. But when you zoom out, like look at the big picture, what happens if a bunch of studies are underpowered? Especially in fields like healthcare or policy, where it really matters. That's what I keep thinking about.
That's a really important point. Underpowered studies, they can have a ripple effect, especially when they're informing those big decisions.
Because if a study's not sensitive enough to detect something real, like let's say a treatment that actually works, but maybe just a little bit, we could miss out on potential solutions, right?
Heck, imagine a trial testing a new cancer treatment, but it's underpowered.
Uh-oh.
It might miss a small but real improvement in how long people live. And then doctors, they see that and they might think, well, this treatment's no good. But really, it could be helpful for some people.
That's a tough one to think about. It really highlights how important this all is. Not just the stats, but the ethics, the big picture impact.
Absolutely. And it goes beyond just healthcare.
Yeah.
Think about education programs or social interventions. An underpowered study could lead to people abandoning a program that could have helped just because the study wasn't designed to see those smaller but meaningful effects.
So we could be missing out on real solutions because the research just wasn't set up to find them.
That's the danger. And that's why understanding power, it's not just for researchers. We all need to be smart about how we look at research. Demand good studies that can actually answer the questions we're asking.
Like we're all detectives trying to figure out the world, and statistical power, it's like a tool in our detective kit. Helps us ask the right questions, find evidence we can trust.
Exactly. We can't just take headlines at face value. We need to look deeper. The methods, the sample sizes, the effect sizes. Does it all make sense?
And to be fair to the researchers, it's not always easy to get those huge samples or control every little thing. Research is messy sometimes.
For sure. But that's where transparency comes in. Researchers, they should be upfront about what they could and couldn't do. Acknowledge the limitations, and journals, media outlets, anyone talking about research, they've got to be responsible too, not just hype up the exciting stuff.
It's like we all need to work together to make research better. Acknowledge the complexity, the uncertainty, and I think it starts with understanding these concepts like statistical power so we can demand better evidence.
I couldn't agree more. The more we understand how science actually works, the better decisions we can make for ourselves and for everyone.
This has been an amazing journey. We've just scratched the surface of statistical power, but I feel like I have a whole new way of looking at things.
Me too. It reminds us that statistics, they're not just numbers. They're tools for understanding the world. And using them the right way, that's how we make progress.
Well said. To our listeners, I hope you've enjoyed this deep dive into the world of statistical power. We covered the basics, the classic view, and even got a glimpse of those newer concepts, like Bayesian power and PPOS.
And remember, this is just the beginning. There's a whole universe of statistical knowledge out there. Stay curious, keep asking questions, and never stop digging deeper.
And if you're interested in exploring some of the resources we mentioned, like that G-Power software or the work of those Bayesian statistics experts, we'll be sure to link them in the show notes.
In the meantime, what's one thing you'll be watching out for now when you see a research study, or even just a headline? Let us know. We'd love to hear from you.
And that wraps up this episode of The Deep Dive. Until next time, keep learning, keep questioning, and keep diving deeper.